Yes, thanks. So just start, I want to acknowledge on the front end. So a bunch of this work, some of these projects were also led by Luis, who worked closely on a lot of these projects. And then my staff research associate, Kevin Godding, and then a graduate student, Maddie Hendrick, also helped out with or did a lot of this work. Okay, so I'm just going to launch in. We work on the primary arthropods we focus on are rice water weevil, tadpole shrimp, and armyworm. I'm not going to talk about rice water weevil, so I'm going to launch straight into some tadpole shrimp work that we've been doing. And so for managing tadpole shrimp, it ends up being a little bit of a race, you know, when you start flooding. Once you add water, eggs hatch, and especially if it's a warm year, the water's warm, things can really get moving really quickly. And so application timing can matter in terms of when you're applying various control options for insecticides, because these shrimp are growing very fast and we could get differences in efficacy based off timing. So we do insecticide trials, and this year the work that we did focused on these mainly using rings this year. So we use these metal rings, and I have a variety of treatments here. So let me see. Oh, that's not going to work. Well, I think hopefully you can see my arrow. So we have a number of different treatments here. I flagged the non-registered ones with asterisks there. And, you know, pyrethroids are used a lot. So that's where we have lambda cyhalothrin up there. And then there are some insect growth regulators in here, some of which are unregistered. So we wanted to test them. And we had a couple different rates because obviously price is a factor. And so if we could get away with lower rates, that would be great. And then also looked at differences in timing because especially with growth regulators, the timing could matter. And then for this material here, so this is cocoa bear, it's actually used to manage mosquito larvae. So we were just giving that a try. And then finally, there are fish there, and those are mosquito fish, and they were put in very early because their mouths are small. And so to get the shrimp in their mouth and be able to eat them, they would need to be present early. And this is just kind of testing out the concept of biocontrol. So this is kind of what it looks like. We relied on natural tadpole shrimp pressure in this study. So just the tadpole shrimp that are around at the Rice Experiment Station. We got a lot, as anyone who's dealt with shrimp can see that it's muddy there. The water's been stirred up. There are shrimp present. That's not all wind. And so here we have the number of shrimp. So we collected counts, and these are just summed across various treatment dates to kind of simplify things. And as you can see, the pyrethroid lambda cyhalothrin worked very well. And when we got Dimilin on early, it actually was very effective, basically zeroed out the shrimp populations. This new other growth regulator, it's not new, it's just not registered in rice, was also very effective. And then we also see that belay was very effective, and cocoa bear is that oil material that's used for mosquito and actually worked to some degree there. So that's actually kind of promising. See that other growth regulator courier there didn't do anything. I'm sorry, that popped up. So for number of dislodged seedlings, because these shrimp can dislodge seedlings, that's some way to damage. We also looked at dislodged seedlings here and counted them. And sorry, I realized this is probably, okay, there. We'll also look at dislodged seedlings, and we see the same general pattern with, you know, the high level of number of fish, pyrethroids, and then these other insecticides there, reducing the number of dislodged seedlings. No, man. Okay. Sorry, I was trying to get it to advance. Okay, so we also looked at yield. Just wanted to present this because someone might ask if we looked at yield. This was yield in the just in those rings. We see some general patterns in terms of the very effective materials tended to have higher yields, but none of these differences were significant. So we also did some insecticide trials with rings. We put these inner buckets so we could actually count the shrimp more easily. So it's a bucket with holes in it, lets the insecticides and water move through it. We generally tested some of the same materials, but we also decreased the rate of dimulant for this. We decreased the rate of diamond there because it was so effective. And just to see if this other insecticide or other growth regulator worked, we increased the rate of that one as well. So here's what we see. So the untreated, we see that there were still a number of shrimp there. We had put 10 in, most of them were still live after 6 days. And a lot of these materials did actually work here, but we do see some general trends there in terms of how rate matters, like for Dimilin, and this is a later timing, so the rate would matter a little bit more there in terms of the timing. So the shrimp are bigger at that point. We did see, again, that this mosquito material, cocoa beer, did actually suppress shrimp there, so that's something that we want to follow up on. Okay, so another thing that we're doing with shrimp is looking at pyrethroid resistance or susceptibility, because pyrethroids are used a lot and there are growing issues with pyrethroid resistance. And so what we've been doing is collecting shrimp populations, figuring out some assays. Here's Luis out collecting some soil that we're gonna rear shrimp from. And we've been trying to rear these shrimp and then test them for resistance. And so these assays are done in some glass jars, just to give you an idea what it looks like. So we have some replication and we're exposing them to different concentrations. So what does this look like? The main point here is what we're doing is trying to figure out the lethal dose of 50% of the population. So what concentration will kill half of the shrimp, and then compare that among different populations. So here's some results from an organic field. So this is the concentration, ounces per acre equivalent of Warrior here. So, but this is with lambda cyhalothrin, a pyrethroid. And we see that the lethal concentration is 0.22. So they're very susceptible. It's below the, fairly below the label rate. So a label rate would kill these shrimp. What we see for some of these other ones, this is a somewhat susceptible population, but it's more resistant, or it's less susceptible to lambda cyhalothrin than that other one. And this was about 6 times as resistant compared to the susceptible. That's what that 6x is. And here we have a resistant population, which we figured was resistant going in based off what we knew. And this is 27 times compared to 27 times more resistant than the susceptible population. This is work that we're doing. So definitely, if you're interested, follow up with us and we can try to gather some shrimp or gather soil and test them. We've been working on figuring out the assay and we think we've got this figured out, and we'll be continuing this work. So what about armyworms? So overall with armyworms, there are generally similar moth captures for the pheromone trapping, which I'll get into. Intrepid was available this year, and then larval pressure was generally low across the region, but there were some spots with a decent number of larvae. So here's the pheromone trapping grid the network that Luis has run. And this focuses both on true armyworm and yellow striped. And if you don't know about this, sign up for it on the UC Rice website. You can get this information in your inbox. And the way these traps work is we're really monitoring the male moths. And so these moths have a sex pheromone produced by the females, and that's what these traps are baited with. So we're collecting the male moths, but that gives us an idea of just the overall populations, since the females are the ones laying the eggs, but we're measuring male moths here. So just overall trend, the 2020 generally looked like 2018. It was in terms of the timing of that first peak, maybe a few more moths on average across the region. And it was a little bit earlier than last year. And again, we see that first peak and then that second peak, which would be, the second peak would be occurring when there's actually grain there's headed out rice. So some other work that we're doing, we're testing some automated traps. The idea here is that it's a better way to detect armyworm. So a camera takes a picture, updates it to the cloud. And the main point here I just want to say is we've been working with these for several years now. This is from 2019. You can see that just overall moth counts there. The bucket traps were catching way more in 2019. And in 2020, we kind of figured it out. And we've kind of started to optimize this trap and get it to work better just in terms of catching the moths. Had some problems in the late season with traps going down, but the idea here is to improve monitoring techniques.
And you have a couple minutes.
Okay. So I'm going to go through this. So we also did some pheromone trap grid to look at some spatial aggregation components of moth captures for pheromones. And so we had a grid here. Our moral of the story, there's lots of variation here. And we really focus just on seeing if we get consistent trap captures. And all I want to say is that on average, there was only one trap or one trapping date where the trap count was consistent between different dates. And so we see a lot of variation there. And are these peaks correlated? So for an individual trap, do we see a correlation between the first peak and the second peak? This scatter plot shows you that it's not. So there is a bit of randomness in trap capture. So that's something that we're going to be working on. We also looked at aggregation of trap captures to see, are there hot spots, or do some traps always catch the most moths? Short answer is no. Most of the time it's random. There were just a couple dates where we had aggregation across our trap grid. So those are those bolded periods. So only a couple dates. And what's that look like? So here's just these are counts. Lots of red equals high counts. And this is just a random distribution. Here's an example of a clump distribution or aggregated where one side of the trapping grid had more. Here the bottom had more. But in general, it was pretty random. And just finally, I think I had this insecticide trial for armyworms. And here we were testing Intrepid, Previthon, and Dipel. And both Previthon and Intrepid work very well. You can see by those blue colors there, they reduced numbers. We had some great reduction from the pre-treatment. And the interesting thing finally there is that there's this reduction in injured panicles all the way through 64 days after treatment. Then I'll just speed through this defoliation trial. So we were also defoliating rice to look at effects of defoliation, different varieties, different defoliation. The key takeaways here is that this is yield. We didn't see a reduction in yield all the way up through 50% defoliation. At 100% defoliation though, we did see a significant effect across varieties and they all behaved similarly and with 26% reduction at 100%, but it was not significant at 50% defoliation. So even cutting them down to 50% height, we were doing this manually, that didn't affect yields. And we only saw this really slight delay in percent heading with one of the varieties, M105, but otherwise we didn't see an effect on heading date. Okay, so that I just want to thank the Rice Research Board for funding and then the work that we did at the Rice Experiment Station and then the grower and PCA cooperators on a lot of this work.
Thank you. We'll quickly do your poll if that's okay.
Okay, so 2 questions. So first, pheromone traps for armyworms capture which types of moths? So either male moths, female moths, or both male and female moths. And then the class of chemicals for which we are most worried about for resistance and tadpole shrimp are the neonicotinoids, pyrethroids, insect growth regulators, or organophosphates. Okay, yeah, let's go over the answer. So yeah, male moths, so again, we use a sex pheromone for these pheromone traps. A lot of pheromone traps are like that, where they use a sex pheromone and the sex pheromones are produced by females, attract the males. And yeah, most people got that it was the pyrethroids. And yeah, so it's various pyrethroids and especially lambda cyhalothrin. It's one of the most widely used pyrethroids.
Okay, thank you.